Hello, my friends. Nice to see you again after some break, but first in this year. And today I'd like to continue with um, a subject that I haven't touched before, because I think we were talking about the principles of the critical thinking. We talked about fallacies of the thinking and the arguments, and how to make good arguments. That's sort of a logic part of it. Now I'd like to stop and pause for a minute and talk about the integration, a little bit on that subject. And I think what is the science of critical thinking has to say about that. What is the thing, and what is the this thing has parts, for instance, or doesn't have parts. Say, a pen, has parts and there's a hole, right? So, I mean, just like in everything, if you can try to break down to the absolute um, kind of a basic level of material being, say atoms or anything below atoms. I mean, let's just not go to the quantum physics, but something at the basic level, we all consist of parts, right? And the parts then make to get something together, and practically at every scale. But let's step up and let's say at our scale here, a chair. I was talking about pen. Maybe it's not a great example because I can't remember parts of it. But let's say chair. Chair has parts. It's great. Chair has parts, and each part of them in metaphysics, right? So you a symbol, it will say, well, a part is a thing. Then the chair is a thing. So altogether, the combination of things produces one thing. So the overall is a number of, let's say, if it's 4 legs to a chair, the 4 parts, and the chair itself, there are 5 things together produce the thing called the chair. Now, why am I talking about it? Does it even matter? Because if you don't want to go into metaphysics, perhaps it doesn't matter. But let's think about ourselves, people, and people all consist of parts, right? But what is the difference between things that consist of other parts and things, but they are not getting integrated? And that's all going to use that word later on, integrate in any way, and the things that are integrated. And the things that are integrated are usually called systems. The things that are not integrated are not called systems. I think they are called sets. So let's just define what the system is. What is talked about when we talk about the system? A system, and I'm just using the dictionary definition, is a set of things working together as part of a mechanism or an interconnected network. So it's a complex whole. Say I have 4, let's say I have 4 cups on a table. They're arranged in some configuration. There are 4 of them, 5 of them. So it's not just 1 cup, one thing, but 2 cup, all these cups joined up together. They are not a system, and they are basically a set. The things that are not connected in any way into a fixture, a thing. A pile of bricks are not connected, so they're not a system. So what is the system? Well, once I build the house or put the things or put these cups in some sort of arrangement, now they are working as part of a whole. Once they work as part of the whole, a very interesting logical thing happen. Suddenly they become more than sum of the parts. The thing becomes more than sum of the part. Like a house is a concept. The house built of bricks is a concept. So if you just had the bricks and mortar, there's tens of bricks and a mortar, doesn't make the house. Only house as a concept appears. And now there is certain interconnection or hierarchy of where these bricks are located in space, yeah, and how they kind of serve a function here. Now that doesn't, this whole concept of a system is very well known in system thinking. It doesn't have to apply to physical objects. It could apply to organizations, networks. So it's or different principles or sets of procedures according to kind of how they're made and how things are done. So number of kind of abstract concepts together get organized, integrated into some scheme of method, and that also is a system, right? So suddenly you have the system of laws. So there are various laws, they get integrated, and there's a system, and suddenly you build up and scale up thing. You scale up a human integrated network, a town, a village, city, a country, a world. And now that's how basically we have all the systems. I mean, everything exists in the world because people build up the systems of governance, governments. Basically, systems are everywhere. Now, if you look at science, you look at how we study things, you actually need to understand how things work, breaking them down to a smallest level. And that breaking down to the smallest level is basically what you do, and you do detailed examinations of elements of structure of something, investigate. And that process of separating something into constituent elements is the important part of the scientific method. You call that part when you do conceive your, remember we talked about induction, and and science is actually induction abduction. So when you kind of gather information from data, but what you do inference then is in analysis. Sometimes, not always. I mean, people say at the end of the paper there's some sort of a grander conclusion, but usually this is not done. Say somebody analyzed a series of samples from, let's just use geological analogy when I'm a geologist, right? Analyzed set of samples from the outcrops, broke them down to the smallest pieces, took all the lives, and then measured the ages. So that is the position. Then you basically publish on that. Yes. Publish the ages, and now would be the end of the analysis. There is also a thing, an opposite to the analysis, is what's called synthesis. And the synthesis is when you, synthesis is basically when you get things organized together, and it's basically, it's a combination of components or elements to form a connected whole. So in order to study the systems, you'll have to do a synthesis of that. And that would be in that scientific example when you go for the when you go to comparatively work with other papers that study the same subjects and try to kind of see the links between various parts of that studies, many studies, and then produce synthesis. It's harder to produce, and it's not always done. I find that science does reward analysis a lot more, because of course that's what achieved a lot. Also remember that this is what's called scientific reductionism. It's a reduction to the basic elements and just drilling down to the basic blocks and then building from these blocks. But what you don't do with analysis when you build these blocks up, you don't actually understand that the systems sometimes have their own interactions that are not just parts of the block. So if you study all parts of those blocks, if you study all the bricks, you still don't understand that there's house. So you'll have to, that's what we call in business stepping back, right? And understanding. People call bigger picture, people call this holistic approach, and all these various names. But actually what you're talking about is, systems thinking. And of course, that is just as part of a critical thinking as the analysis. It's just in a different way. So what are the elements of the synthesis, right? So when you look at the systems thinking, the systems very potentially very complex. I mean, you're talking about, say, human systems, like social network. Yeah, that's a system. It is extremely complex. A relationship between different parts are not always obvious. But I mean, even that, say, climate models, they have complex feedback loops. They don't react in the same way because there are too many parts influencing other parts. So whereas, and then there's not always a causal understanding that there is a causal understanding of something. Now you might say, well, the science hasn't really gone to the bottom of it, but there are so many issues associated with it's very hard to actually get to the to drill down to every basic element and just even, I don't know, maybe at some point that sort of science will be written. But these kinds of relationships very difficult. That's why biology, chemistry, and something, but a lot of the biology, geology, and these, and climatology, they are basically very much in the systems thinking. Whereas the basic science, I'd say, it's very math driven, and the basic science, physics, maybe astronomy, all these things could be very well understood as part of the analysis, and they actually make great equations. You can't make equations for people behavior, at least the emergence of that's not very clear. It's unpredictable. So human behavior is unpredictable, as we learned. The combination of various peoples behaving together, although it follows certain laws, and these laws could be expressed, but these laws are basically part of the system thinking. So take an example of a corporation. Corporation has it's not a thing it's a concept. It's not a thing that you can touch. It consists of various departments, human resources, R&D, publication, and obviously there's CEO at the top, and various consultants, and workforce. That corporation is a system. The parts cannot be understood as separate from the whole. If the bricks of the sets of, here, these are basically just a disorganized, it's not even possible to have it separately. So it's basically one organism, and it sort of has its own nervous system, its own, activity sets on brain, and all of this works together. None of the parts can be independent, and this organization is more than sum of the parts. So there are parts, and there is a network. You can call it sort of influences, directions between different parts of the organization, and it's a complex one. And even though you know you could study behavior, there are laws, or ordinances, or in you can let's forgot the word, but let's say there are rules and regulations. You can study rules and regulations. You can implement them. You can also study people behavior and influence people behavior. You can correct uh, issues, but there's also outside influence that you have to get into the out into the system that you don't know influence of, and then outside obviously hugely influences the system from inside. And then if you kind of all get all the brew, the outcomes could be unpredictable. I mean, they don't, now the organizations obviously continue along, but very, very often the things produced create unintended consequences. That is why, and that is why it's so hard and difficult to govern. Political, problems, public housing, networks, taxes, and you say, why couldn't anybody solve this? Why would that? Well, because a problem that has been solved in one way, in one way, the system will obviously create an unintended effect, unintended consequences later down the road from another part. Now, if you look at it holistically, if you could have, you might have in some ways predicted it, but it is very difficult. And it's actually right now, I mean, you can model all you want, but it's unpredictable. You can see it now with the energy issues that happened last year. And yes, there is currently an understanding that the climate will warm up to 1.5 degrees according to IPCC. Or forget if I am wrong at the figure numbers, but and then the climate will do X and Y, but climate will do Z. It will not do X or Y. It will do something that has not been predicted because the system is so complicated. I mean, it's just that it's much bigger than some of all the parts that you can model. So you can imagine, how much things you have to model to get things right. You have to model all the constituent parts or input parameters, and also relationships between all these input parameters. And obviously we do a lot of modeling to understand the systems, but modeling is difficult and it's an approximation. So just to reiterate, simple set doesn't have any relationship between other parts of these things together, so they're not a system. And you don't need synthesis to understand how these work. Yeah, a number of people at the bus stop standing together in a bus, they're waiting for a bus, are disorganized, and they're not a system. However, if they go into the bus and there is a fire and they run out, and they form a disorganized network. Yeah, so they be so you need to understand their behavior. Yeah, so they could easily change it into system. There is a simple system like a house, and there is a complex system like a corporation. Now, just coming back to the integration that here. So what is the integration? Yeah, it's a word that has many meanings. Yeah, I mean, it's just a process of combining something, combination or amalgamation, incorporation, and so on. That it comes from the word integral, right? So it's something that my definition here would be something that you do when you apply systems thinking at your daily work. Pretty much every time we do more than one task or chore, we are integrating them. We're integrating our daily lives, the work that the family has to do. I mean, it's obviously planning a vacation is an integration of various bits and pieces. Yeah, ordering the ticket, calling up the hotel, or getting the car ready, going place, and settling in, going to visit visit a new location, while it's already sort of in that new place. Doesn't matter. I'm just saying this is a very simplistic thing. But at work, what we do is basically, and then the business is all about trying to integrate various pieces to provide an answer. So in case of the business, that will be a business decision, has to be a business decision, has to be fed by an integrated analysis and synthesis. So you'd have to obviously analyze your data, understand and drill down to your data, then combine it in some way that is simplified, presentable, and synthesized to produce an answer, a path forward. Remember, we talked about the data, information, knowledge pyramid, and inference at the top. It's kind of like that. That's how I see it. I see it's the basically the you end up with a triangle, and the triangle at the bottom, you have this kind of disorganized data, and then the data gets analyzed, and then bits of information and are provided, but the information is called knowledge. Now it's funny, but that's what I would say. Then an analysis doesn't get knowledge complete, and it's not necessarily wisdom. So what gets you to wisdom is when you are able to synthesize and integrate all of that work together to actually produce something which is really having you make wise decisions, and that is an integration. So system thinking is a very important part of that. Very important part of the understanding the integration. Analyze, synthesize, wrap it up, integrate, and don't forget about how complex the systems are. So I think maybe illustrate later on a few examples of how the systems are how they're more complex, and we'll deal with issues of critical thinking there. So scientific method applies, of course, and it's just more complex. And we haven't even touched. We talked about logical fallacies. We haven't even touched, our human difficulties and cognition on all these various issues. So I think we'll touch on that as well. But I think maybe that's just my first rant for this year, and I hope to see more of you. Maybe I'll continue on that subject. In the meantime, if you are interested in, please click on the bell there and subscribe to my channel, and also supply me any new thoughts that you want me to cover in that area. I'm more than interested to have a discussion with any of people who want to. Thank you very much. Bye today.